Let me show you my 4-bit breadboard calculator. This is my first ever electronics project, designed and built by myself while learning how things work. In this video, I will show you the functionality of the calculator, how it can be used, and maybe in a second video I will go into more details and describe how it works. Perhaps I should mention that I had a rough idea of an end result when I started, and as I went along building it, I was simultaneously working on the design of new features and deciding how to implement certain functionality. Of course, it's a simple electronics project for somebody more proficient than me, but it gave me some challenges and problems to solve and a great deal of fun working with. And I'm happy with the result. A working 4-bit breadboard calculator. Now I will show you how my breadboard calculator can be used. It is a 4-bit calculator, meaning that the input numbers A and B have 4 bits written in binary, and therefore can represent every integer ranging from 0 through 15. For A and B respectively, we can count up by increasing the number by 1, and this way choose the numbers we want. When we get to 15, increasing by 1 will get us back to 0, since there is no 5th bit needed to represent the number 16 and above. At any time, we can also reset the count back to 0 by pushing the reset button for A or B. The numbers are displayed both in decimal form with these 7-segment displays and in binary with LEDs. In addition to choosing the numbers to use in our calculation, we also have to pick an operation to use. The available operations are addition, which is the default with no LED turned on, it's subtraction, and it's multiplication. The current operation is also indicated by one of 3 LEDs down by the result display. Let's begin with addition. Now that we have our input numbers ready and have decided on which operation to use, we are ready to calculate. We do so by pressing the calculate button, and the result will show up in the row of result LEDs in binary. If we turn the result display on, it will also be shown there as a decimal number. If we now change one of the input numbers, let's say we increase A by 3, this LED will light up, indicating that the result probably is inaccurate and need to be recalculated. The display is also turned off. So we press the calculate button again, and a new result is shown in the display. Let's try to change the operation to subtraction. Again, the LED indicating that the recalculation is needed is lit up and the display turns dark. Pressing the calculate button now gives us the answer to 5 minus 8. It's -3. And the second LED by the display indicates it's a subtraction. The third operation is multiplication. Let's press this button to switch to multiplication, and again, pressing the calculate button will show the result. Perhaps you noticed some flickering of the display and some LEDs when we multiplied. Now I will show you what really happened by slowing down the calculation process. Multiplication is calculated as repeated addition where the multiplicand b is added repeatedly. How many times is determined by the multiplier a. This button controls the calculation speed, and by pressing it we can slow down the clock that is running the multiplication as repeated addition to actually see the sub-steps in the process. If we start the calculation now, we will see the value of the multiplier a in these 4 LEDs, slowly counting down in sync with the clock, indicated by the yellow LED, and stopping when it reaches 0. For each step in this cycle, the value of the multiplicand b is added to the preliminary result, giving the final result on the calculation when the clock stops. This way we can follow the multiples of b up to a times b on the display. We can try to calculate some higher numbers and follow the multiples as the multiplication process goes on. We can set a to 10 and b to 15. Now we can follow 15 being added 10 times. 15, 30, 45, and so on. And 150 is the final result. So, this was a demonstration of my 4-bit breadboard calculator. Thanks for watching.